All right, so today we're going to be talking about linear equations. I'm going to turn off the lights so it's a little bit easier for you guys to see. No falling asleep. I'll throw the book at you, literally and metaphorically. So I think you guys are on chapter 2, right? You guys are still in chapter 2?
Yes.
Right at the end of chapter 2. Where I'm gonna teach a chapter 3 lesson. Deal with it. That's what's going to happen. So the underlying concepts here, though, that we're going to be going over are linear equations, which are, there's an example of a linear equation right there, and linear equations specifically in standard form. Before I start that, though, let's move on to...
Okay, don't go to the restroom. Okay? Carter, don't go to the restroom. It'll be after lunch, okay? I'll probably call you out, just depends. If they get here, I'll find you at lunch, we'll come do it. If not, they'll call you out of class. I'm not sure what time they're gonna get here. Brett, don't go to the restroom. Allie, don't go to the restroom. What? You know what that means?
Yeah.
Okay. Finish.
Wait, what?
All right. Fantastic distraction. Back to the lesson. Okay. So, I have here the graph of an equation. Can I get your attention, please? Thank you. All right, I have here the graph of an equation, specifically the graph of this equation. But can anyone tell me what these equations all have in common?
They all intersect?
Sure, yeah, they all intersect. But even at a more basic level, can anyone tell me what they all have in common?
They're all straight lines.
They are all straight lines. Fantastic. So we call equations whose graphs are straight lines, we call those linear equations. In fact, you can even see in the word linear is the word line. Pretty straightforward, huh? So then, what does it take for an equation to be linear in that case? You can definitely see that all of these equations, which we've just determined are all linear because their graphs are straight, all these equations look very different from each other. There is, however, one thing that all these equations have in common, and that is that they all have at least one unknown variable, in this case either x or y. So an equation can have anywhere up to 2 unknown variables. I'm going to pass out some notes for you guys to go over as we are going through this lesson. Yep.
I love the book.
Oh, thank you. Thank you. You are. All right. So, looking at these notes, I imagine the first 2 blanks should be able to be filled in by now. We've gone over them already. So then, an equation whose graph is a
Line.
line, but can you be a little bit more specific?
Graph on a, graphing paper?
Straight line.
Straight line. That's exactly what I'm looking for. You can have an equation whose graph is a curvy line, and we will look at some of those in a second. But yes, the answer to the first blank is certainly a straight line. Second blank, these equations can contain blank or blank variables. So I'm looking for a number here. How many variables did I say that a linear equation can have?
1 or 2.
1 or 2. Great. Alright, going back to the presentation then. So now, in your notes, the next thing that we'll go over is the restrictions, which an equation must have to be linear. Is this line linear?
No.
It's not a straight line. The equation of this, which is here, this blue equation, is not linear. However, these two equations are very similar to each other. There's one subtle difference, which
One
is
squared.
one is squared. The x value in particular in this case is squared. What do you guys think this equation will look like, where the y value is squared?
Like this.
It'll be flipped like upside down on the bottom half
Okay,
of the
so
graph.
I
It's like
have,
this, it's from side to side.
yeah, I have one person saying that it'll flip upside down, one person saying it'll be side to side. What's the rest of the class think?
Whatever the other people think.
Yeah, I already heard what they think. What do you think?
I don't know.
You don't know? Can't even take a guess? You think it'll be a diagonal line?
Yeah, sure.
Okay. Alright, well you're way off. The other two are much closer, I'll give you that. Let's start with yours then, huh? So you think it will be a downward facing parabola?
Yeah, it'll like flip.
Well, I can tell you that we can manipulate this graph where the exponent is on the x term very easily to get the graph that you were saying, where it's a downward facing parabola. And it's still our x term which is being squared,
But
not
it's
our y term.
negative.
It's just negative, correct? If it's positive, it's an upward facing parabola. However, this is the graph of the quadratic equation where the y term is being squared. So you were indeed correct. Again, we could get it to flip the other direction if we turn the negative into a positive, it'd be facing the other direction. But the important thing is that either of those lines that I showed you, the four lines I showed you, where it's an upward facing parabola, downward facing, or a left or right facing parabola, none of those lines are straight lines. None of those lines are linear equations. So one of the restrictions, which you can go ahead and put down now, is that it cannot contain exponents. Either of the variables can't contain exponents. So let's move on to the next restriction, which, as the title may imply, radicals. So let's look at the graph of an equation which has a square root in it. It looks quite similar to an equation which we just looked at. Not that one, however, there we are. It looks a lot like that equation, except for it is only half of it. We can get the other half of it by introducing a negative in front of the exponent, or in front of the square root, that is. However, both of these lines, either half that you have it, are not straight lines still. They're still curved lines. We can analyze this one as well. Again, it is an upward facing half of a parabola. We could get it to show the other side if we simply just change this to a positive, similar to the last example. Either way, none of those four lines which I just showed you would be straight lines. Therefore, one of the restrictions that you guys can write down is that in order for an equation to be linear, it cannot contain square roots. Which leaves us with two more restrictions to fill out, correct?
Yep.
Moving on to logarithmic equations, which is perhaps a term which you don't need to know. It just felt fun to write it down. We have here an equation with x in the denominator. And we have here an equation where x and y are being multiplied together. So let's take a look at those graphs. With x in the denominator, it's very clearly not a straight line. In fact, it actually appears to be two separate lines, both of which are neither straight. Similarly, if we look at the equation where two variables are being multiplied together, neither of these lines are straight lines. In fact, they appear to be two separate lines. So I think it's pretty safe to say that if an unknown variable is in the denominator of an equation, it will no longer be a linear equation. So that is a restriction which you can write down now. And likewise, if two variables are being multiplied together, the equation is no longer a linear equation, is now a nonlinear equation.
So cannot be divided or cannot be multiplied?
It's not that it can't be divided. You can have an equation, or you can have a variable be divided by something, right? X divided by 3 would still be a linear equation. In fact, if you, it's not important. What is important is that it can be divided by something. However, you can't divide by an unknown variable, which means that your unknown variable can't be in the denominator of an expression. So that's a great question. And finally, the fourth restriction would be that you can't have two unknown variables multiplying each other. So, just in case you guys haven't got them, these are your following restrictions. Does everyone have these written down? Yep. No. Let me know when you do.
What does number 3 say?
Number 3 says no variables in the denominator. Can't divide by an unknown variable.
Madison, don't go to the restroom.
Okay.
Okay.
Okay, does everyone have these? Alright. Moving on. I'm going to give you a few examples of some linear and non-linear equations. I mean, we've already looked at some examples just using the program, but this way you can have some in your notes to refer back to later. So one of the easier linear equations which we could have, x minus y equals a constant, right? So this equation is linear because neither our x value nor our y value is being raised by an exponent. Neither of those terms are being being taken the square root of. Neither of these terms are multiplying each other. Neither of these terms appear in the denominator of the expression. Another example, one that just only has one variable, x equals 9. As I said earlier, linear equations can have one or two variables, and as long as none of the restrictions are still broken with just one variable, again, this is not being squared, this is not having the square root taken of it, and it's not multiplying another unknown variable, and it's not in the denominator of an expression, this technically still is a linear equation. And we've already looked at an example of what this would look like. Equations which have variables are some type of diagonal line. Whereas this equation, x equals 9, would end up being a vertical line, crosses the x-axis at x equals 9. Both of these lines will still be linear. In fact, we don't even have to call our unknown variables x or y. We could have something outlandish as 48s plus 59t equals 3. And that is still a linear equation because it does not violate any of the four restrictions which we've gone over. So some examples of nonlinear equations. Can anyone tell me what an example of a nonlinear equation might be? Doesn't have to be too complex.
X squared minus y
X squared minus y
equals 0.
equals 0. Fantastic. That is in fact a nonlinear equation because your x term is, oops, that's a weird arrow, is being squared. How about another example of an equation which breaks one of our restrictions? Yep.
1 divided by x equals 3.
Equals 3. That works, yeah. Totally, because our x appears in the denominator of this expression. Another example? Yeah, what do you got?
Like x in a square root box minus y equals 0.
Now, I could have misheard your example just now, and I could have heard it as x minus y equals 0. Would this one be linear, or would this one still be nonlinear?
When it comes out of the square root.
If both of these unknown variables are inside of the square root, is it still going to be nonlinear? Because I agree with you that this one is certainly nonlinear.
Mhm.
How about this one?
Yes.
Yeah. Why do you say that?
Because it's still not, square root.
And our restriction was that no unknown variable can be in a square root. And in fact, both of these ones are. So it breaks our restriction 2 times. Very unfortunate for this core equation, it never stood a chance. Can someone give me one final example of an equation which does not qualify as a linear equation? Sure, what do you got?
X times y plus 3 equals 5.
Fantastic, yes. This breaks our 4th restriction, stating that unknown variables cannot multiply each other. This would result in one of those wacky graphs, which looks like it has 2 curved lines. Great. Let me know if anyone's still writing these down.
I am.
Okay. Next, we will have a couple of practice examples. So if you guys want to go ahead and start working on those, they should be relatively simple. I just need you to identify if the equation is linear or nonlinear. If it's linear, just write yes. If it's nonlinear, write no. But make sure you circle why it's nonlinear in the equation. It should take you about 2 minutes to do it. So go ahead and move on to that. And we'll talk about it in a few minutes. If anyone has any questions, feel free to turn to someone next to you just to verify a few things if you need it. It should, like I said, be pretty straightforward at this point. We haven't gotten into too intensive of subject matter. Let's start with this first problem then. Has anyone got an answer for this?
I believe it's linear.
You believe it's linear? Can you tell me why you think that?
Because it does not break the rules of, wait, does it? The x and y is multiplying by each other, but that means,
Can someone help them out? Yeah, what do you got?
I would say it's no because x and y are, well, they're multiplied together even though that they're in the equal area.
And so, would we ever be able to undo some of these operations in such a way that we could rewrite the equations so that they aren't multiplied together?
you could cancel x out on the on the front side.
On this side?
Yeah.
How would we cancel the x out?
You can divide by 5.
Divided by
Or
5
divide
cancels
by
the 5
x,
out.
yeah.
So
But-
subtract 1x, or divide 1x.
Divide 1x. So if we divide by x on both sides of the equation, we certainly would cancel these 2 x's out, leaving just y over here. However, and these 2 x's would cancel out as well. However, you still have to divide this term by x. So you would end up with x in the denominator there, which breaks our 3rd restriction, which we said.
Can't divide by.
So you can't divide by an unknown variable. So if you do try to do the algebra out, you still end up with an expression which is nonlinear.
So it's not-
Just as this one was nonlinear because these 2 terms were being multiplied together. Does that make sense to everyone? Yeah. How about number 2? And how about someone who hasn't spoken yet? Looking at you, middle row. You don't know?
Redhead, the redhead.
No one wants to take a stab at it? Yeah, what do you got? You put yes. Why did you put yes?
Because I don't think it's breaking any of the rules.
It's not breaking any of your rules. I'll agree with that. One thing that may be a little bit cosmetically tricky is that it kind of looks like this x may be in the denominator there, but since it's outside of the parentheses, you should know that it is not in the denominator. In
Ours
fact,
doesn't have parentheses, so that does
You-
count.
oh, yours doesn't have parentheses.
Yeah, so that's why I was up with it.
The only reason I put parentheses is because of, when I was typing it out, right, the way that it actually fell out, it kind of looked like it was 3 over 4x.
Yeah.
Your guys' should be a little bit more vertically oriented as a fraction. However, this x, it has an understood 1 underneath it, meaning that it's in the numerator of the fraction. So that doesn't violate one of our restrictions. As you were saying, it doesn't violate the rest because we can see that neither of these unknown variables are raised to an exponent, neither of them are contained within a radical, neither of them are scaling another unknown variable. So yes, I agree, this equation is in fact linear. I didn't write it down explicitly here, but this one is not because of this term here. How about number 3? Who's got an answer for number 3? Yes, you with purple hair.
Yes.
Yes. Similar to the last example, in fact, perhaps a little bit easier than the last example because it doesn't have this little tricky notation here. You can see that it doesn't break any of our 4 restrictions. And number 4 should be quite easy. Yep,
Non-linear because it has
Non-linear.
a square.
perfect. So we have no, yes, yes, no. I hope that's what everyone got. If not, make sure you have it now. It's your last chance. Moving on to the back side of your worksheet, we'll be discussing linear equations in various forms. So just to take a look at what these may look like using our program here. I have here the graph of an equation. Would you say this equation is linear or nonlinear?
Linear.
Linear. Now, as you know, we can basically manipulate an equation however we want to come up with an equivalent equation. So, with that in mind, and by the way, this is the visual representation of this graph. This is the equation for that. What would this graph look like?
So y equal.
Like this. You think it'd be going the other direction with a negative tendency? Okay, well, you're at least partially right. You're right that it will still be a straight line. That should be a pretty natural inclination, because just by looking at this, we can see that it's not breaking any of our 4 restrictions, which we've just gone over.
Since it has, since it's 1x, wouldn't it be
Think it'd be a vertical line?
Yeah.
You're kind of on the right track. I like your thinking there. But since it does still contain a second unknown variable, it will not be straight up or down, straight side to side. In fact, what it would look like
Same thing.
is the exact same thing. So these equations we could say then are equivalent. They're just different representations of the same equation. Thus, the graph of these 2 equations fall along the same points. How about this one, this third one, which is a slightly more complex version of these equations? What would the graph of this line look like?
Same exact, yeah, I would say same exact thing.
Yeah, it is the same. Is it the one's just times it by 1, so it's
Yep, indeed, it is the same exact thing. As I think you're hitting on there, you can manipulate this algebraically by distributing your 1 inside the parentheses, and then you could subtract, or you could add 100 to both sides to cancel out these, and then you're left with an equation which looks exactly like this. This last example I have down here is not technically an equation, right? There's no equal sign, so it's not technically a linear equation. I more have put it on there for a little bit of fun. This is just the representation as
1x.
1x, right? The function 1x, which is still the exact same graph. So this was really just an attempt to show you that there are multiple different ways which we could express linear equations. They are still, in fact, all linear, even though they may look drastically different from each other. The specific form that we will be focusing on today will be standard form, which is this first representation. So to press onward then, a linear equation in standard form takes this structure, where you have ax plus by equals c. Your x and y's are unknown variables. Earlier in this lesson, I mentioned that it doesn't matter which variables you use, right? You can use x and y, you can use z and w, you can use q and whatever other letter you choose to use. In standard form, that's not the case. In standard form, you have to use the variables x and y. So if you are given something with different variables other than x and y, you simply just have to change them. No big deal. However, what is a big deal is the order in which these terms appear. First, your x term shows up, then your y term, followed by the equal sign and one solitary constant on the other side of the equal sign. You cannot have any unknown variables on the right side of your equal sign in standard form. They all have to be together on the left side. And A, B, C are arbitrary constants. They'll vary from case to case. So let's take a look at some more restrictions. The first restriction, which I've kind of just given to you, is that your x and y terms have to be together on the same side of the equal sign. Additionally, another restriction would be that you can't have fractions anywhere in the equation. If you do have fractions, to turn it into standard form, you'd have to undo those fraction operations. We'll get into that a little bit more in just a moment. But let's proceed onward with the other three restrictions. This one may be the most notationally intensive restriction. Both a and b cannot equal 0. And that is not to say that a can't equal 0 or b can't equal 0, but they both can't be 0 at the same time. In fact, if we wanted to, we've already looked at a couple of examples where a or b are 0. So if we let our b equal 0 in this case, we would have a times x plus 0y equals c. This can simplify a little bit because 0 times anything is just 0. So we would have ax equals c, which again would just be a straight line, up and down. Similarly, if we let a equal 0, we would be left with 0x plus by equals c. This can simplify down to 0, leaving us with just by equals c, or the horizontal line. But if both a and b were equal to 0, we would no longer have variables in our equation. We would just be left with 0 equals c, which is simply saying that c is 0. We no longer have a line. We just have a c value at that point.
It would just be a dot.
It would just be a dot, yeah, exactly. Very good. So that is a quite important restriction to point out, because if you violate this restriction, you no longer even have a line to look at. Whereas, at least if you violate the first restriction with no fractions, it would technically still be a line. It just would not be a line in standard form. So our third restriction, pressing onward, is that you cannot lead with a negative. Which just means that A can't be negative. It's perfectly fine with B or C to be negative. In fact, most of the examples which we looked at on that graphing software, our B value was indeed negative. But what's very important for standard form is that you cannot lead with a negative number. That one's pretty straightforward. This next one, however, is probably the most complex out of the 4 restrictions. Must simplify. Can anyone tell me what they think that possibly means?
It can't equal out to like one variable equals this. It can't be like simplified out to one answer.
Yeah, and I would agree with that, except for these equations which only have one variable in it. You could definitely get one solid answer from that equation. So you're very close in that. Yeah, what do you have?
Isn't it where like the variables on each other that equal sign?
I'm sorry, say that again?
The x or y is on each other the equal sign.
That is something that we need for this to be in standard form. But that doesn't necessarily imply that it's in most simple form. So what that means Let's say, for instance, we have an A value of 2, a B value of 6, and a C value of, say, 10. That would make our equation be 2x plus 6y equals 10. Now, so far we haven't violated any of our first 3 restrictions, right? There's no fractions in this. The A value is not a negative 2, it's a positive 2. And A equals 2, B equals 6, neither of those are 0, so we should be good on those first ones. However, we can simplify this equation. By dividing both sides of the equal sign by 2, we now have an equation which looks like this, which is in fact an equivalent equation. There's no difference between these two equations other than a cosmetic appearance of them. However, this is now in simplest form because both 1, 3, and 5 are all prime numbers. They can no longer be reduced. So if you can reduce all 3 of your all 3 of your constants, which should be known, if you can reduce all 3 of those, then your equation is still not in simplest form. And you will thus need to put it in simplest form in order for the equation to ultimately be in standard form. Now, does everyone have all these restrictions written down? I will take your stunned silence as a yes.
Yeah.
All right. Now, finally, we're moving on to the last examples. These ones will take you a little bit longer to do. Still, it shouldn't take you a long time to do them. What I need you to do is rewrite the equations in standard form. They're the exact same equations you have in your notes. Rewrite them in standard form and then identify the 3 constants, A, B, and C. I'll give you guys 5 minutes to work on this because it is a little bit harder than our previous example. And then we'll go over them as a class.
Wait, so you mean like in simplest form as in, like are we supposed to do it in simplest form? As in like get the prime numbers and...
Yeah. So one of the restrictions for an equation to be in standard form, which is what this question is asking you to do, it wants you to put this equation in standard form. One of those restrictions is that the equation is in simplest form. So go ahead and work through as many of them as you can, and if we run into one which could be simplified, we'll go over that together as a class. All right? But you should certainly look to see if your equation, which you think might be the answer, you should certainly check to see if it is in standard form. You should see if it could be reduced in any way. If not, then it is likely in standard form already. I should see everybody working. I don't expect any of you to be done already. So I want to see everybody trying to work these problems out for themselves before we go over it as a class. Yeah, you got a question?
Yeah.
What's up?
Number 4, wouldn't it already be simplified? Because it's ax plus by equals rc.
So you think it's already in standard form?
Mhm.
Alright, well then you can just go ahead and box it if that's what you think the answer would be.
I think number 1 is in standard form.
It can't be both variables on the same side.
Alright, let's talk about it. Who thinks that 1 is in standard form? We have one brave hand raised. So some of you who didn't raise your hands, tell me why it's not in standard form.
Because both variables.
It's got a fraction.
It's got a fraction. And what were you saying?
Both variables are on the same side of the equal sign.
Right, so it's actually breaking 2 of our rules. Any suggestions as how we can write this in standard form? What our first step should be?
Shouldn't your first step be to get rid of the fraction?
Sure, we can do either one first. It's merely a preference. So how would we get rid of that fraction?
Would you subtract it to the other side? Or,
Okay, we can try that.
I don't know.
X minus 3 over 4 equals y.
Mhm. And then would you do that again, but subtract x and put it on the other side, and that leave you negative 3/4 over or equals y minus x?
Okay.
And then to get rid of the fraction.
Don't you
So-
multiply by its reciprocal
Multiply by its reciprocal.
to get rid of it?
Yeah, that actually totally would get rid of the fraction. That's a very good inclination. Because by multiplying by its reciprocal, which in this case would be negative 4/3, your 4 values would cancel, your 3 values would cancel, these negative signs would cancel, and you'd be left with 1 on this side of the equation. However, what you do to one side of the equation, you must do to the other side of the equation. Multiplying this side of the equation by negative 4/3 will in fact still leave you with a or with a fraction in your answer, right? You would be left with negative 4/3 y plus 4/3 x. Still, our equation has fractions in it and is thus not in standard form. So I like your instinct to multiply by the reciprocal. However, let me suggest a slightly easier fraction to multiply by. Fix this real quick. So we were at negative 3/4 equals y minus x. If we multiplied both sides of the equal sign by 4 over 1, we would still get these terms to cancel, then leaving us with negative 3 equals 4 times y is 4y. 4 times negative x is negative 4x. And now we have an equation,
That gives you your A, B, and C.
which we could identify our A, B, and C at this point. However, one of the first things I said about standard form of linear equations is that you need to lead with your x term. Your x term must come first. So if we were to rewrite this algebraically, we could add 4 to both sides of the equal sign, or 4x that is. These terms would cancel out. You'd have 4x minus 3 equals 4y. You need your y terms and your x terms to be on the same side of the equal sign. So to do that, we can subtract by 4y minus 4y, leaves us with 4x minus 4y minus 3 equals 0. We're very close, we just need to move this constant to the other side, which would give us 4x minus 4y equals a positive 3. I believe this equation is finally in standard form. If I'm wrong, someone please tell me if I've broken any of our standard form restrictions. What was that?
Actually,
So please don't waste.
kind of. I mean, I didn't think I was gonna be able to get that one, but I did. So at least I think.
So this is now in standard form. We're leading with our x, followed by our y, equal to a constant. We can check our restrictions. We're not leading with a negative value first. We have no fractions. What are some of our other restrictions?
They didn't lead with-
negative.
Can't leave with a negative, check, we've got
Both
that.
A and B do not equal out to 0.
Okay, yeah, that's correct, because A is 4 in this case, B is negative 4. So let's go ahead and quantify those. A equals 4, because A is our constant, which is multiplying our x term. B is what?
4, negative 4?
Is it 4 or negative 4? Negative 4? Very good. And that leaves C to be
3.
3. Fantastic. So yeah, we have officially put this equation in standard form. And we've identified our 3 constants. Let's move on to number 2. Who can tell me if this is in standard form or not?
It is not.
It's not.
No.
So what's the first thing we should do so that it would be in standard form?
So divide by 5 on each side to like the x.
It doesn't, it's okay for our x to have a term next to it. That would be our a term.
Yeah.
If we did divide by 5, we would end up being left with a fraction over here and a fraction over here. And as we know in standard form, we can't have fractions.
Like subtract by 5 on the right side of the, and like, so get that 5 off right there, yeah.
How
There you
about we
go.
just subtract 2? Because that would be reverse and
You want to subtract 2?
2, we want to subtract 5 by 2
I see.
and remove
I think what you mean to say is subtract 2x
on both sides.
on both sides, correct. Which leaves us here with 3x equals 5 plus y. We know that to be in standard form, our equation needs to be ax plus by equals c. However, our y is on the wrong side of the equal sign.
Subtract by y on each side.
Subtract by y on each side, which leaves us with 3x minus y equals 5. Is this in standard form?
Yes.
Correct. We're not leading with a negative number, because both x and y are not equal to 0, because there's no fractions, and because this equation is indeed in simplest form. 3, 1, and 5 are all prime numbers. Neither of them can be reduced with respect to the other, so we can verily say that this is in standard form. So then, what would our a, b, and c values be?
Our A is 3,
Okay.
B is 1, and C is 5. Negative 1, and C is 5.
B is negative 1. You can't forget about the subtraction sign. C is equal to 5. Very good. Now I've got one here hidden in the middle, so I'm going to be erasing this first problem. I hope everyone has it written down. Very good. Okay. So x equals 10. Is this equation in standard form?
I said yes. I thought it was.
Okay, so we have 1 for yes. Who else?
Yeah.
Oh, so you're shaking your head no?
I don't think so,
Why is that?
because there's one variable,
There's only one variable.
yes.
Okay. I see where you're going, because you understand that linear equations can only have one variable, but what you're trying to get at is that for a linear equation to be in standard form, it needs to have both variables.
Yes.
Is that what you're saying?
Yes.
Okay. Well, let me suppose this to you. Let's actually start this one by trying to identify our A, our B, and our C values. I think we may actually be able to get to the root of the problem here.
A would be 1.
A is 1 because A is the term that is multiplying our x variable. And since we haven't understood 1 next to all of our variables, A would be that 1.
Would B be 0?
B would be 0.
And C would be 10.
C is 10. So if we were actually to explicitly write this out, which I think is where you kind of got snagged up, we would have 1x plus 0y equals 10.
But
So
that's
now how
our
about
A,
that?
B, and C. Good. That's simple.
So would you say that this representation of this equation is in standard form?
Yeah.
Okay. Well, I would suggest that this representation of that equation is simply a simplified version of this equation. Therefore, I would say that this equation is in fact in standard form. So you can go ahead and box this one, because that will be your answer for an equation in standard form. And these would be your A, B, and C values. So very good. That one could be quite tricky if you didn't immediately notice that B should be 0. Let's move on to number 4. Is this one in standard form?
Yes.
We have one yes. Anyone else? Yes, 2 yeses. We got a hand on the cheek in absolute boredom. What do you think?
Mikhail?
You have no idea. You don't even want to take a guess?
I don't know.
I mean, you're on film right now, man. Like, this is, the whole world's gonna see this. You want them to remember you as not even trying to guess this problem?
Sure, yeah.
You think it's in standard form.
Yeah.
And you think that not because people around you told you so, but because you developed your own ideas on this matter, correct?
Yeah.
All right, great.
Our A would be 2,
A would be 2.
B would be 4, and C would be 10.
Correct. That is what our A, B, and C would be if this equation was in standard form,
Can
yes?
you simplify it?
You could certainly simplify it. How would you simplify this?
Divide by 2.
Divide by 2. You have to divide the whole thing by 2 or multiply it by 1/2, however you prefer to do it. But whenever you do so, you're left with x plus 2y equals 5. Now, is that in simple or in standard form?
Yes.
Yes.
Very good. That's one of the harder restrictions to notice, is the equation must be in simplest form.
Yeah, I knew that.
And I knew that this problem would be tricky because of that. That's why I put it on there.
So our A would be 1.
A is 1, B is
2,
2, C is
5.
5. Very good, very good. So then this would be our answer for the equation in standard form. These would be our A, B, and C values.
Are you even allowed to put A, B, or C as a fraction?
I'm sorry, what?
Are you even allowed to put A, B, or C as a fraction, or does that have to be a whole number?
No, because one of our restrictions is that this
X was
equation
2y.
can contain no fractions. That's our first restriction.
You have 2 minutes.
What? 2 minutes. Ooh-wee. Time flies, right? You're having fun?
Oh yeah,
Oh, yeah.
I have buzz.
5 hours.
Wow.
Yo, no, I have fun.
Will you be teaching us lesson 2 more?
No, unfortunately I won't. I wish I could, actually, but I can't.
Are you gonna be here at all anymore?
Yeah, I'll be here next week.
Okay.
What was the question?
Why do you like doing that?
That's a good question, actually. I kind of think of math as being this little puzzle, right? Whenever you have a puzzle, you open the box and it doesn't make a whole lot of sense. Right? It's all jumbled up together. But there's one solution to a puzzle, right? Like, whenever you put a puzzle together, you're not going to have your corner piece be in the bottom corner. It's going to fit exactly where it should. And to me, mathematics is exactly like that. Mathematics is a puzzle which you solve and you get one answer. To me, mathematics is very gratifying in that way. Whenever you write a paper for an English class, it's very subjective. You don't know if you did it right, you don't know if you did it wrong. With math, you definitely know if you did it right. You get a very distinct answer. So that's why I like doing math. Additionally, math is this universal truth, right? Every culture has math. Every culture has very different languages. Every culture has very different social norms. Every culture has very different histories. Every culture has the exact same math because math is a universal constant. Not very many things in our reality are universal constants the same way that math is. Thank you guys very much.
Thank you. That was actually
Thank you.
I actually understood, so.
I did kind of read that, but
Thanks.
I get out. I don't know.